In this lesson, I am going to talk about regarding the false position method. So I use this figure to realize this method. First, our function must have opposite signs on the bounds of the interval. Then the function definitely intersects the x-axis and has a root. In this method, the key idea is to approximate the curve by a straight line within the interval and identify a false position such that x2 Here the points of A and B are joined by a straight line that intersects the x-axis and the point of the intersection is x2. Now check the sign of the fx2. It has negative sign. Fx1 have positive sign. Therefore, the root is between x2 and x1. Again, the points of C and B are joined by a straight line that intersects the x-axis and the point of the intersection is x3. Also, check the sign of the fx3. It is negative sign. Therefore, the root is between x3 and x1. So, this is the process. And we have to do that again and again until the root is found. Now I am going to take an equation for the false positions by using the straight line of A and B. So get the gradient of the straight line in two ways. So let's see how to do that. And this is the straight line of A and B, and also I have taken any point xy on the straight line. Now I have taken the gradients in two ways. The first way is the y minus fx naught over x minus x naught is equal to fx1 minus fx naught over x1 minus x2. After solving this part little bit, we can get this equation. Here x minus x naught goes to this direction and fx1 minus fx naught goes to this direction. X1 minus x naught goes to this direction. So finally we have this equation. Now when the straight line of AB intersects the x-axis, y is equal to 0 and x is equal to x2. Therefore finally we have this equation. Therefore we have x2 minus x naught is equal to minus fx naught over fx1 minus fx naught times x1 minus x naught. So when x minus x naught goes to right hand side, we have x2 is equal to x naught minus fx naught over fx1 minus fx naught times x1 minus x naught. So this is the equation for the false position of x2. Now I am going to take the general equation for the false positions. So obtain the general equation for the false position method. I use this figure here. This is our function. This is the function in between xl and xu. For the xl, fxl have negative sign, and for the xu, fxu have positive sign. Therefore, our root is between xl and xu. Here xr is the point which the straight line intersects the x-axis. So let's see how to get the general equation for the xr. So again we have to get the gradient in two ways. The first way is the y minus fxl over x minus xl is equal to the fxu minus fxl over xu minus xl. So I have taken x minus xl to this direction and fxu minus fxl to this direction, also xu minus xl to this direction. So we have x minus xl is equal to y minus fxl over fxu minus fxl times xu minus xl. So at the intersection point, y is equal to 0 and x is equal to xr. Therefore, we have xr minus xl is equal to minus fxl over fxu minus fxl times xu minus xl. Therefore, finally we have xr is equal to xl minus fxu over fxu minus fxl times xu minus xl. So this is the general equation for the false positions. Now we are going to understand this method properly by solving an example. Example number 1. Find the root of s cube plus x plus 1 equal to 0 correct to 3 decimal places on the closed interval -1 and -0.5 by using fold position method. So first it is essential to check if the function has opposite signs. Otherwise, the straight line drawn between 2 points of the curve will not intersect the x-axis. It means, in this figure, this is our function in between -1 and -0.5. Then you can see that for the x1 equal to -0.5, function value have positive value. Also for the x0 is equal to -1, function value has -1. Then this function has opposite signs. It means this function definitely intersects the x-axis and we have a root. Now we are going to find the fold position x2. We have opposite signs, then we can continue the process of the fold position method. So first iteration x2 can be found using this equation. Then I have taken x1 is equal to -0.5 and x0 is equal to -1. When substituting these values to the equation, for the x2 we have minus value. Now we need to check the sign of the fx2. When substituting the x2 value to the function, we have negative sign. It means the root is between x2 and x1 because fx2 have negative value and fx1 have positive value because I have taken x1 is equal to -0.5. Therefore, f -0.5 is equal to positive value. Therefore, our root is between x2 and x1. Also, to find the x3 value, I can use this equation. x3 is equal to this value and if x3 have negative value. Therefore, our root is between x3 and x1 because if x3 have negative value and fx1 have positive value. Now create a table and fill it in using the scientific calculator. So expressing choice equation of the fold position method by using the letters in the calculator. Therefore, the general equation of the fold position method represent by using the letters on the calculator. XR represented by capital X, XU represented by capital A, XL represent capital B, FXL represent by capital D, FXU represent capital C. Actually, in your answer sheet, these things you don't need to write, but these things you can write another paper. So let's see how to create a function to enter the calculator. You know that we need to find the positions by using this equation. In this equation contain A, B and C, D. A and B are our input values. C and D are our function values when A and B substitute to the function. Therefore, first we have to enter these two equations. Then D is equal to B cube plus B plus 1 and colon mark. Also C can be represented by using A. C is equal to A cube plus A plus 1. Again colon mark. Now we can represent our equation which are using to find the position value. Therefore, it's x equal to A minus C over D minus C times B minus A. Again colon mark. Now again we have to check the function value for each position. Therefore, we represent the function here by using x cube plus x plus 1. Then entering this function to the calculator, we can easily fill this table. Now I am going to enter this function to the calculator. So D is equal to B cube plus B plus 1 colon mark. Enter C is equal to A cube plus a plus 1, again colon mark. Now x is equal to a minus c and d minus c, b minus a, b minus a, again colon mark, x cube plus x plus 1. Now click the calc button. Now we are going to enter the values, input values a and b. In here I have taken a is equal to minus 0.5 and b is equal to minus 1. But if we want to get a is equal to minus 1 and b is equal to minus 0.5, it doesn't matter. Finally you can get the same answer. Now we are going to enter the input values. Therefore b is equal to minus 1, equal button for the a minus 0.5, equal button. Then we have d is equal to minus 1, minus 1, again equal button. Then c is equal to positive 375, again equal button. Then we have minus 0.6363636. Actually, before entering the function to the calculator, you need to calculate a fixed 9 decimal places for more accurate solution. So here I have fixed this calculator for the 9 decimal places. Therefore, finally this value rounded for 9 decimal places. Again equal button. Here we have positive value 105935387. Now we know that for this position function value is positive. Therefore our root is between a is equal to this value and b is equal to minus 1, d is equal to again minus 1, and c is equal to this value. Now we go to the calculator. So b is equal to minus 1, it is not change. A is equal to capital X alpha x, and d is equal to minus 1, c is equal to this value, and x equal to minus 0.671195,652. The function value is positive 428288. Again our root is between this value and minus 1, again minus 1, d is equal to this value. B not change, a is equal to alpha x, d is minus 1, c this value, x equal to minus 0.679661,646. Function value is positive 0.006375484. Again b is equal to minus 1 and a is equal to x. B is equal to minus 1 and also d is equal to minus 1. C is equal to this value. Again a is equal to x, d is equal to -1, c is equal to this value, x equal to -0.681 691 0 to 0. Function value is again positive 0.001 525 358. Again b is equal to -1 and a is equal to this value. B is equal to -1, D is equal to -1 and C is equal to this value. A is equal to x, D is equal to -1, C is equal to this value and x equal to -0.682 175 816. Function value is positive 0.00364 Again our root is between this value and -1. Again -1, C is equal to this value. B is equal to -1, A is equal to x and D is equal to -1, C is equal to this value and x equal to -0.682291533. Again function value is positive 0.000086928. Again our root is between this value and -1. Again -1, C is equal to this value and here A is equal to x, D is equal to -1, C is equal to this value and x equal to -0.682319148. Function value is 0.000020744. Therefore our root is -0.682 for 3 decimal places.